In this demo, we are going to see how to get started with Simulink and Simulink support package for Arduino to control a Bobot. For this, I have MATLAB, Simulink, and Simulink support package for Arduino installed. If you do not have the support package installed, go to the Add-ons tab in MATLAB and click on Get Hardware Support Packages to download and install the support package. I have an Arduino Duo and an assembled Bobot along with a USB cable for this demo. The assembled Bobot shown here has an Arduino Duo connected to it, and the board is powered using this cable. I'm connecting the 5V pin on the Duo to the positive terminal on both the servos and the ground to the negative terminal. Here is a close-up of the connections which show how I have connected the servo signal wires to pins 9 and 10 on the Duo. To connect the Duo to this PC, I am connecting the USB cable to the programming board. To get started with Simulink, let us open the library browser by clicking on the Simulink library icon in the Home tab. The library browser shows all the blocks that are available from all the installed toolboxes. To create a new model, we can click on this icon inside the library browser, which opens up an empty canvas. We know that we want to control a Bobot and also learn Simulink. So let us go to the support package for Arduino and take a look at all the blocks that are available. When you hover over the blocks that are available in Simulink, a simple description of what the block does will appear. Here we can see that there are blocks that enable us to communicate with the analog, digital, PWM, and serial pins of the Duo. The standard servo rate block sets the shaft position of the motor to the input value mentioned, whereas the continuous servo rate block sets the speed of the motor. For our task of controlling the Bobot, we need to use the continuous servo rate block. Servo motors in general may turn or vibrate when they are getting a standstill command. This generally means that the motor has not been centered yet. To center the motors, let us send out a 0 velocity to both the servo motors using Simulink. Change the pin values to match the actual pin numbers as per the hardware connections. The Simulink tab in the library browser has commonly used block in which you can find the constant block to send 0 velocity to the servo motor. To connect the block, Simulink's Smart Editor provides you a suggestion which you can accept by merely clicking on the line. The other way to copy-paste blocks in Simulink is to right-click on a block and drag while holding the right-click button down. I'm saving this model as Bobot trimming, as trimming is another commonly used name for centering the motor. The mode of simulation for this model is normal, and the other one, which is of relevance, is external. External mode provides you with capabilities to modify parameters while the code is running on the hardware and also to monitor signals inside Simulink. To be able to modify the velocity command that goes to the motors, I am going to change the mode of simulation to external. To configure this model to generate code for Duo, we can go to Tools, Run on Target Hardware, and select Prepare to Run. When you select Arduino Duo for the target hardware, Simulink will take care of the rest and attempt to automatically identify the COM port on which Duo is connected. The workspace now has a cam object that represents the connection that MATLAB has made to a webcam. I'm going to use my webcam to show the centering process as I'm doing it while Simulink is still sending 0 velocity command to the servos. I changed the value to infinity so that I can get enough time to finish the process. The preview function here can be used to show the webcam output on my screen. If you look closely at the servo motor that you have, there will be a small knob which you can control to change the speed of the motor. Our goal while centering the motors is to stop both the wheels while a 0 velocity command is being sent to them. Once we are done with centering the motors, I'm going to change the value of constant blocks to 90 and -90 to check the direction of motion for both the wheels at their maximum speeds. During the process of centering the servos, I had the Bobot tethered to my PC. Now it is time to make the Bobot go in a loop using Simulink. I'm removing the constant velocity input to one of the motors, and I'm going to use a repeating sequence block to send different commands. I'm changing the value of output and time vector to these values so that one of the motors can go at maximum speed for 1.25 seconds, at 0 for the remaining time. This, along with the other motor going at a maximum speed always, will ensure that the Bobot goes around on a loop. Now I'm going to change the simulation mode to normal and then click on Deploy to Hardware button so that the Bobot can run independent of Simulink. Simulink gives us a status update on the bottom left corner on what it is doing, and after it has generated and downloaded the code, I've detached the USB cable, and here is a preview from the webcam on what the Bobot is doing. With that, we have seen how to use Simulink to generate code for Arduino Due and control a Bobot.